Hi, everyone. Welcome to our Oracle CloudWorld presentation on hybrid database as a service for DevOps. My name is Martin Pena, and I'm joined by Alfredo Krieg, and we'll be going through the topics and giving you an overview of Oracle Enterprise Manager and how it can be used for hybrid database operations. Again, my name is Martin Pena, and I'm Senior Director of Product Management for Oracle Enterprise Manager, responsible for database lifecycle management capabilities, as well as the Enterprise Manager platform. Joining me today will be Alfredo Krieg, and he is a Master Principal Security and Management Platform Specialist. So for our brief presentation today, we're going to give you a quick overview of Oracle's manageability strategy. We'll talk about Enterprise Manager, some of the key strengths and the directions for the product. And then we'll go into some of the key technologies that support hybrid database management, including database as a service, our cloud management pack, and some of the other automation tools. After that, I'll turn it over to Alfredo, who will give you a deeper dive into the specific ways that hybrid cloud management can be implemented. So let me go ahead and start with our management strategy for both the on-premise and enterprise and the cloud. And really, our strategy here is to provide a maximum choice to our customers across these two different platforms. So for Enterprise Manager, this is a product that's been out for over 25 years and initially was focused on on-premise solutions. But this really provides a tool for deep management of the complete Oracle stack, not just the database, but other components as well. As we've evolved the product, we've grown it to incorporate management for areas such as hybrid and multi-cloud support. We've also really focused on enhancing the ops automation support. And we've modernized the platform to provide additional resilience and extensibility for our customers. On the cloud side, we provide a complete array of management cloud services. So these include new services for application performance monitoring, log analytics, database management, stack monitoring, and big data analytics. So really, all the different components across the different stacks that are required to manage the cloud. So let me talk a little bit about the focus for Oracle Enterprise Manager. As I mentioned, this product has been out for many, many years, and the focus continues to evolve. In our current release, which is Enterprise Manager 13.5, we focus on these three main pillars. The first one being hybrid cloud management, which is the ability to manage any of your targets regardless of platform. So whether they're on-premise in your data center or in the cloud, Enterprise Manager should be able to monitor and manage those and provide you value for that management exercise. In addition, we focus on ops automation, which is really providing enhanced automation to make doing your day-to-day jobs and more strategic jobs more automated and provide better efficiency for your administrator staff. And lastly, we provide extensibility and resilience on our platform. So really, we realize that Enterprise Manager is not the only tool in your data center. So we try to provide hooks and integration with other tools that will enable you to enhance your management capabilities. So as we focus on these three pillars, we also realize that our customer requirements and system management requirements are evolving. So as customers take that journey from on-premise to the cloud, really the combination of these three different components becomes very important. So on the hybrid cloud side, administrators will manage on-premise and cloud with a single tool. So really a single pane of glass to manage everything you need from both platforms. In terms of ops automation, the requirement here is to automate management operations at cloud scale. So this is really something that we've focused with Enterprise Manager for a long time, is we not only manage single targets, but really groups and sets of systems at the enterprise and fleet level. And then finally, we focus on extensibility. So as I mentioned before, the ability to extend interoperability across other tools in your ecosystem. So Enterprise Manager is not assumed to be the only tool in your data center, but we enable it to communicate and share data with other management tools. So let me provide a little bit of a preview and introduction for what Alfredo will be talking about. So let's start with hybrid cloud management and what the expectations are here. So really the idea here is that you should be able to monitor and manage your entire hybrid fleet. So that means everything from your traditional data center targets to things like Oracle Cloud Customer Solutions like Exadata, and also public cloud services. So really enterprise manager should be a single pane of glass to manage all three of these different components. We also think that hybrid management should be aware of new cloud targets such as Autonomous Database, Exacloud Customer, and Exadata Cloud Services. With these tools, we should be able to identify any hotspots across these different platforms, and we should be integrated very closely with the Oracle Cloud Infrastructure Platform in terms of being able to provision, manage, and observe the lifecycle of these various tools. We also want to focus more deeply in the area of database as service in the hybrid environment. So this means the ability to provide self-service deployment across all these different platforms, but also to be able to provide self-service governance tools so that you know that these targets, when deployed, are conforming to your various compliance standards and performance standards. So let me drill down quickly into one of the key products which enables this functionality, which is the Cloud Management Pack. And this is really built to extend the data center to the Oracle Cloud and help you manage multi-tenant databases across hybrid environments. The objective here is to really improve the agility of rapid provisioning of databases. We want to enable you to deploy pre-configured service levels with these targets, and also to be able to consolidate and maximize the infrastructure associated with maintaining these database targets. So let's take a quick look at some of the core features and capabilities. So the main objective here is really to help increase the quality of service. So we realize that in terms of DevOps, people want to be able to deploy databases quickly, but also to be able to enhance the quality of service of their database targets. We want to be able to rapidly provision and deploy databases using standard components and configurations. So this really means being able to implement service levels across your various targets. And we want to be able to introduce space-efficient cloning. So this is the ability to take very large production databases and quickly and efficiently clone them with minimum space. And finally, we want the ability to be able to track the usage of these different components. So we've introduced metering and chargeback capabilities. So this really enables administrators and management to observe the resources involved in these provisioning exercises. So the Cloud Management Pack is designed to help set up what we call a private database cloud. So this means that you can create your own cloud within your own private data center. So you can create a fleet or an infrastructure of database components, and on top of that, build and deploy and operate the services as you would a normal cloud. So this private cloud gives you the enhanced ability to maximize the visibility of the components, to do monitoring and reporting, and ensure adherence to your own internal IT standards. And so our various models that we support with this are the ability to build this on top of virtual machines, shared cluster databases, pluggable databases. So it's a really very flexible model here. Some of the other benefits associated with this Cloud Management Pack and Database as a Service are the ability to empower dev teams. So really it enables non-DBAs to be able to very easily deploy databases out of a pre-configured service module. We can reduce database sprawl and security risk by knowing exactly what databases have been provisioned. And we can rapidly clone and mask large production databases that can be used for QA purposes, testing purposes, or development purposes. By knowing exactly what kind of resources we deploy, we can improve cost control. So we can improve the overall resource utilization through consolidation, making sure that we're utilizing resources as efficiently as possible. And we can improve accountability, make sure that all the resources utilized are the best for the different types of services that we're deploying, and give management the capability to observe how much storage, memory, and other resources are being consumed for these services. So finally, before I turn it over to Alfredo, let me talk a little bit about database as a service and why this is important to this solution. And really, database as a service is our set of features and solutions that help customers simplify self-service deployment of databases, at the same time help you standardize deployments, and also consolidate databases so you're using resources as efficiently as possible. So here's a high-level diagram of database as a service and what's involved here. And you'll see really that some of the benefits are efficiency, accessibility, elasticity, accountability, and integration. In this environment, we have a infrastructure which is completely database agnostic. So we can use various types of databases, which include dedicated databases. We can use pluggable databases and even thin clones. And we have the ability to utilize on-premise databases, cloud services, or even clouded customer type solutions as well. So really a very flexible architecture that gives a lot of flexibility for our customers. In terms of pluggable database as a service, this is really a great new way to take advantage of both database as a service and the multi-tenant architecture. So again, this is going to really reinforce the consolidation benefits, enabling customers to really reduce the resources required to run multiple services and applications, and also enable the ability to scale up and scale down without introducing any runtime. We have the ability as well to provide standardization. So we know with this type of model that any database that is deployed conforms to whatever service levels we've specified in the background. And we also provide automation at scale. So again, we can provide this automation not only on a single target, but multiple targets. So not only can we provision them easily, but also we can do day-to-day maintenance functions such as backup, et cetera, at scale across multiple targets. And all this is really going to help deliver a lower cost of ownership for our customers. Just a couple quick things before I turn it over to Alfredo. Here I'd like to introduce our database as a service self-service portal. So this is part of the Cloud Management Pack. And what this does is provides a self-service portal that can be utilized by non-DBAs, very easy to display what database services have already been provisioned, what their status is. We can drill down and look at some high-level management capabilities, but also we have the ability here to provision new database services, and we can also see at a glance the high-level usage of various resources such as memory, storage, CPU, et cetera, for this entire environment. So this is a way that a self-service user can observe what they've provisioned. So with that, I'll go ahead and turn it over to Alfredo.
Thank you, Martin. So let's start with hybrid database as a service for DevOps and what it means for customers that want to extend their data center to Oracle Cloud or vice versa and manage multi-tenant databases across hybrid environments. In this slide, we have an example where we have several data centers. So customers, by deploying database as a service, can now enable self-service users to leverage all the templates that Martin just discussed in previous slides in the service catalog in order to provision new databases, either on the Oracle Cloud Compute, VM, bare metal, as well as on Exadata Cloud, in addition to on-premises infrastructure. So as you can see, we're agnostics in terms of infrastructure. Once you have established the connectivity between on-premises and OCI, you can use the same REST APIs to provision and manage databases on premises and in the Oracle Cloud. So that's one of the features of Cloud Management Pack, that the REST APIs that we're exposing can be used in order to provision all those databases. Doesn't matter which infrastructure are you using in the background of Enterprise Manager. So now the self-service user interface can be used in order to deploy new databases on demand, update those databases at scale with minimal downtime, you name it. But how you can have complete control of your private cloud using Enterprise Manager, the cloud management pack that we just discussed, and all the features and offerings that Enterprise Manager has for you. So starting with database administrators. Database administrators can still use the Enterprise Manager console they've been using for years, right? So you can log in and start using all the features that we have for Cloud Management Pack in terms of provisioning databases, moving databases around. But most important, the database administrator is still the one responsible for setting up all this infrastructure for end users. So don't worry about losing control of your environment. Database administrators are the guys that are responsible of setting all these quotas, governance, and all the service catalog offerings for end users. So now developers can use the self-service portal in order to log in and start requesting databases using all these offerings that the database administrators created for them. We have another option to use all these features for the Cloud Management Pack, which is EMCLI scripts or REST APIs. And this is where we start connecting Enterprise Manager with all these third-party tools. It could be DevOps tools, CI/CD pipelines, orchestration engines, you name it. You can consume all these REST APIs in order to start requesting all these offerings coming from the Cloud Management Pack. One quick example that we have from customers is that right now they're able to use DevOps tools or orchestration engines to request and provision virtual machines, for example. Inside these virtual machines, they can provision applications. The problem comes when they need an Oracle database. So they go manually and they open a ticket to the database administration team. And it's quite of an effort for the administration team in order to provision Oracle databases manually, right? So it can take from weeks to months in order to have those databases up and running. And the point is, it's not only provisioning Oracle databases, but what about all the setup for monitoring? You want to monitor all those databases, right? You want to have those databases under metering and chargeback, for example. So right now, everything's manual. Well, with the Cloud Management Pack and all the automation that comes from Enterprise Manager, they can now close the loop and finalize the automation process in order to provision those VMs, provision those applications, last but not least, provision the databases, even the data needed for the application, connect the application to the Oracle database, and finalize the flow for that automation process. But how the segregation of duties works in database as a service. And I just gave a glance on the previous slide about the administrator, which is part of the database administration team most of the times, is responsible of creating these resource pools of Oracle database homes or database or container databases that are going to be hosting those pluggable databases, creating the quotas, creating the service templates, which are like a menu for your end users where they can see what your offerings are and start requesting them. Set up charge plans, which is really important, and finalize and configure all the request settings. At the end, the end result for that is that they're going to have all the setup ready in order to use database as a service as a platform in Enterprise Manager. Then we have the end users, which are the ones logging in into Enterprise Manager using the self-service portal, selecting the database from the catalog, configuring the database if needed, configuring backups, and getting the database ready for use for their applications. But now how you can fit DevOps inside this database as a service offering from Enterprise Manager? Well, as we mentioned, on the right side of the screen, we have all the, the administrators that set up all the platform for end users. In this case, setting up pools, zones, all the Oracle Homes Rack databases, container databases, all the data needed for the application. Setting up the quota, the placement management. The quota and the governance is really important, correct? We have the service template creation, service catalog management, even fleet maintenance in order to enable end users to patch their own databases, just clicking a button. On the left side of the screen, we have end users that can request database services, request data services, monitor and manage deploy databases, delete service databases, and so. Now we fit DevOps in the middle. DevOps can also help you configure some of the tasks inside the cloud management pack, but most important, you can automate all the process of requesting databases, requesting services, monitor and manage those databases, and last but not least, also delete service databases using DevOps automation. So we mentioned that the administrator is the one responsible of setting up this platform for end users or third-party automation and orchestration tools. This is a quick overview of the steps needed in order to set up a database as a service inside Enterprise Manager. You can either use EMCLI commands or you can use the UI. So step number one is to set up the software library, and the software library is the one responsible of holding all these images in order to provision Oracle databases. You will install platform software like Grid Infrastructure, Oracle Homes, container databases that will host those pluggable databases. Set up the pool on a specific host. As we mentioned, you can use either on-premises, engineered systems, cloud targets, you name it. Provisioning profile and service template creation. Set up access controls. As we mentioned, governance and quotas are really important here. As optional, you can set up charge plans with we strongly recommend. After that, end users will be able to use all the offerings from the database as a service platform. We have some REST APIs available where you can start hooking those third-party tools with Enterprise Manager. So we divided those REST APIs depending on if you're the requester or you are the provider. And as you can see, we have REST APIs for the requester, and we have EMCLI commands for the provider. So you can still execute some of the provider responsibilities using automation tools, but most likely you will have your database administration team controlling all the provider options. On the requester side, though, they can use REST APIs in order to create database services, list deploy databases, service templates, patch databases, delete instance databases, and so on. For the requesters, for the providers, though, so they have complete control of their private cloud. And as we mentioned, they have two options. They can use EMCLI commands, like the example that we have on the bottom of the screen, or they can use the UI in order to configure database as a service. Going back to the REST APIs for providers and consumers. So we have divided the REST APIs depending on the operation that you may execute against Enterprise Manager. So you can list zones, you can list the service templates, list service instances. In terms of deploying services, you can request databases, request pluggable databases. You can request schemas inside pluggable databases, but also track the request progress of those services. Manage all those services like start and stop pluggable databases or standard databases. Request a backup, request a restore, and a snapshot clone of pluggable databases, or even hooking that to a snap clone and create a snap clones of databases. Also get chargeback information. What is your resource usage during a period of time? Last but not least, we have delete operations like delete service or extend the reservation in case of if you are enabling expiration settings inside database as a service. Last but not least, I want to show you here what is the request flow using hybrid database as a service for DevOps. And this is just a quick example on how you can start requesting databases and control all those Oracle databases using Ansible. On the left side of the screen, I have a JSON script that is part of an Ansible playbook where we're calling REST APIs that Enterprise Manager is exposing in order to be used by third-party tools. So what we're doing here is basically we're requesting a pluggable database using an offering that was already set up by the database administration team. Okay. If the database administration team doesn't create those offerings, right, then you cannot consume them, basically. Once we query which offerings are available, then we can start requesting pluggable databases with Ansible. We will have to pass a couple of parameters like username and password, the name of the pluggable database, and things like that. But a part of that, we pass those parameters using the REST API that we're going to consume. And Enterprise Manager will automatically schedule that specific request. You have several options for scheduling, of course. You can say, go ahead and execute that request now. But also you can say, well, I want to go ahead and schedule this for this weekend, next month, you name it. Once Enterprise Manager creates the request, it's going to be executed internally based on all the configuration that the database administration team previously created for that specific request, and the pluggable database will be created. You can see on the right side of the screen that we logged in using the self-service portal, and the end result is having that pluggable database PDB1 basically created using that Ansible playbook. One last thing that I want to mention is that I really recommend you to get familiar with Oracle Live Labs. And remember that Oracle Live Labs give you access to Oracle's tools and technologies in order to run a wide range of labs and workshops. In fact, we have two workshops that will cover all the steps needed in order to set up, connect, and request pluggable databases using Ansible and Enterprise Manager. The only thing that you need to do is log into Live Labs, and on the upper search bar, just type the code Ansible, click enter, and you will see that we have two workshops available for you. Workshop number one is going to allow you to deploy and manage Oracle databases with Ansible and Enterprise Manager. And workshop number two is a little bit more advanced because we have that integration with fleet maintenance. And what we're going to be doing is patching a pluggable database using Ansible and Enterprise Manager. Thank you very much for attending this session, and we look forward to seeing you at one of our demos in the exhibit hall or one of our sessions for hands-on labs.